Hello students, everyone. Good morning. In today's class we will see some theorems based on diagonals of rhombus, rectangle and square. First of all, see theorem based on rhombus. Prove that diagonals of rhombus bisect each other at right angle. Prove that diagonals of rhombus bisect each other at right angle, and then after that we will see theorem based on diagonals of rectangle and then square. Clear? So see, first of all, diagonals of rhombus bisect each other at right angle. This we have to prove. Our first step is given a rhombus ABCD, and second step is to prove OA is equal to OC, OB is equal to OD, and angle AOB. See the figure. ABCD. This is your rhombus, and diagonals here is AC and BD, which intersect at O. So we have to prove OA is equal to OC and OB is equal to OD, and angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOA is equal to 90 degree. Angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOA is equal to 90 degree. Bisect each other at right angle means these angles must be equal to 90 degree. See the proof. We know that rhombus is a parallelogram. We know that rhombus is a parallelogram, and diagonals of rhombus we know that rhombus is a parallelogram and diagonals of parallelogram bisect each other. Therefore, OA is equal to OC, and OB is equal to OD. Therefore, OA is equal to OC and OB is equal to OD. Therefore, diagonals of rhombus bisect each other. And now we have to prove bisect each other at right angle. So bisect each other clear, and now we have to prove bisect each other at right angle. So take triangle, take any two adjacent triangle. In triangle AOB and triangle AOD, we can take any two adjacent triangle. Take angle AOB and angle AOD. In this we have side AB of triangle AOB and side BA of triangle AOD is equal because it is side of rhombus. and sides of rhombus are equal. All sides of rhombus are equal. Then AB equal to DA and OA is equal to OA common. OA is equal to OA common, and we just prove OB equal to OD and OB equal to OD. We have proved. So triangle AOB congruent triangle AOD. Clear? So these both triangles are congruent, and when it is congruent, then angle AOB is equal to angle AOD CPCT, corresponding part of congruent triangle. Is it clear to everyone? Now see, both angles are equal. Angle AOB is equal to angle AOD, corresponding part of congruent triangle. When two triangles are congruent, then their corresponding parts, that is their corresponding sides and corresponding angle will be equal. Therefore, angle AOB is equal to angle AOD, simplicity. But angle AOB plus angle AOD is equal to 180 degrees. Why it is? Because it is linear pair. Angle AOB plus angle AOD is equal to 180 degree linear pair. And now see, angle AOB is equal to angle AOD. Both our angles are equal, and sum of both angles is equal to 90 degree. Therefore, both angles will be equal to 90 degree. Therefore, angle AOB is equal to angle AOD is equal to 90 degree. Clear? Similarly, we can prove. We can prove angle BOC is equal to angle COD is equal to 90 degree. Therefore all angles are 90 degree here. Therefore angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOA is equal to 90 degree. Proof. Clear? See the proof of this theorem again. This is a rhombus whose diagonal bisect each other at right angle. Given here is a rhombus ABCD. We have to prove OA is equal to OC and OB is equal to OD. And second, we have to prove angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOA is equal to 90 degree. Clear? See the proof. We know that rhombus is a parallelogram. And diagonals of rhombus bisect each other. Therefore, OA is equal to OC and OB is equal to OD. Therefore, diagonal of rhombus bisect each other. Now see, bisect each other, but it bisect at right angles. So for this we have to prove any two adjacent triangle to be congruent. In triangle AOB and triangle AOD, AB is equal to DA, and OA is equal to OA common, and OB is equal to OD. We just proved. Therefore, AOB congruent AOD, and therefore AOB is equal to AOD CBC, corresponding part of congruent triangle. Clear? But we have AOB plus AOD is equal to 180 degree linear pair. So AOB equal to AOD is equal to 90 degree. Similarly, we can prove by taking these both triangles. We can prove angle BOC is equal to angle COD is equal to 90 degree. So we have AOB is equal to BOC is equal to COD is equal to DOA barabar 90 degree. Clear? So this theorem is clear to everyone. Now we will say diagonals of rectangle are equal. So again we will prove diagonals of rectangle are equal. Second theorem we will see, prove that diagonals of rectangle are equal. So first of all, make a rectangle. Rectangle ABCD, whose diagonals are AC and BD. Whose diagonals are AC and BD. So given, first step is given a rectangle ABCD. Given a rectangle ABCD, and to prove diagonal AC is equal to diagonal BD. This we have to prove, and this theorem is very simple. See, AC is equal to BD. We have to prove AC is equal to BD. Second step is to prove, and there is no construction here. Prove in triangle DAB, in triangle DAB and triangle DAB and then again CBA, in triangle DAB and triangle CBA, DA is equal to CB. Opposite side of rectangle are equal. Opposite side of rectangle are equal. Clear? DA is equal to CB. And second one is DAB. Angle DAB is equal to angle CBA is equal to 90 degree, because each angle of rectangle is 90 degree. Clear? And AB is common in both triangles. AB is equal to BA is common in both triangles. Clear? Therefore, triangle DAB is congruent to triangle CBA. Clear? And therefore, BD of triangle DAB and AC of triangle CBA will be equal. Why it is equal? Because this corresponding part of congruent triangle. Clear? And these both triangles are equal by which criteria? Side and angle and then side. Both triangles are congruent by SAS. Side angle side criteria. And if both triangles are congruent by SAS, then we have BD is equal to AC, CPCD corresponding part of congruent triangle. Therefore, diagonals of rectangle are equal. In this way we can prove that diagonals of rectangles are equal. Clear? Now see one more theorem of rectangle, that diagonals of rectangle bisect each other. Prove that diagonals of rectangle bisect each other. Now third theorem is prove that diagonals of rectangle bisect each other. So given here is rectangle ABCD, and to prove is angle side OA is equal to OC and OB is equal to OD. Diagonals of rectangle bisect each other. First we have proved diagonals of rectangle are equal, means AC equal to BD, and then now we are proving that diagonals of rectangle bisect each other, means OA is equal to OB and OC and OB is equal to OD. Proof. ABCD is rectangle, is a rectangle. Therefore, AB parallel CD and BC parallel DA. Now AB parallel CD. Now AB parallel CD and AC is transversal, and AC is transversal. Therefore, angle 1. Angle 1 means what? Angle OAB. Angle 1 is equal to angle 2. Alternate interior angles. Clear? Because AB is parallel to CD and AC is transversal. Again, AB parallel CD and BD is transversal. AB parallel CD and BD is transversal. Again, AB parallel CD and BD is transversal. Therefore, angle 3 is equal to angle 4. These are also alternate interior angles. Clear? Now in triangle, see, now in triangle AOB and triangle COD. In triangle AOB and triangle COD. Angle 1 is equal to angle 2. AB is equal to CD, opposite side of rectangle. Opposite side of rectangle. Angle 1 equal to angle 2 we have proved, and angle 3 is equal to angle 4. This also we have proved. Therefore, by ASA, angle side angle, therefore triangle AOB congruent triangle COD by angles and side angle criteria. And therefore, angle side angle criteria by angle side angle criteria AOB congruent COD. Therefore, side OA of triangle AOB will be equal to side OC of triangle COD. Clear? And similarly, side OB of triangle AOB will be equal to side OD of triangle COD, because these are corresponding part of congruent triangle. Corresponding part of congruent triangle. OA is equal to OC and OB is equal to OD. This we have to prove. So it is proved when both triangles are congruent, then their corresponding sides as well as corresponding angles will be equal. And for proving two triangles to be congruent, we must have three conditions, and here three conditions are: angle 1 is equal to angle 2, alternate triangle, AB is equal to CD, opposite angles of opposite side of rectangle, and angle 3 is equal to angle 4, again alternate triangle. Therefore, AOB, triangle AOB will be congruent to triangle COD by ASA criteria, and therefore side OA of triangle AOB and side OC of triangle COD will be equal, and again side OB of triangle AOB and side OD of triangle COD will be equal. So this is the proof of this theorem. So today we have done 3 theorems. So you every students make practice of this theorem at least 3 times. Do practice of these theorems at least 3 times. Means 3 3 are 9. 9 times you can prove. You can practice it and show me your work in offline class, which is going to start from Monday. Till then, goodbye.